Ever wondered why deserts, rainforests, and tundras exist where they do? It all comes down to one system, a 150-year-old climate map still used today. Let's explore the Koppen-Geiger system and how it shapes the world you live in. Every region on Earth experiences a unique climate, some sweltering under tropical heat, others cloaked in polar ice. But how do we make sense of all this climatic diversity? One of the most effective tools for this purpose is the Köppen climate classification system, a system that has shaped modern climatology, geography, and environmental science for over a century. Today, we'll explore how this system works, why it remains relevant, and what it can tell us about the world we live in. The Köppen system was first introduced in the late 19th century by Vladimir Köppen, a German-Russian botanist and climatologist. At the time, climate studies were mostly qualitative and lacked standardization. Köppen brought a new level of rigor and objectivity by linking climate patterns to natural vegetation, what we call biomes. Did you know that? Köppen was also instrumental in developing the first global climate map and contributed to early research on climate change and ice ages. Köppen's idea was rooted in a simple observation. Plants are excellent indicators of climate. They respond to two key variables, that is, temperature and precipitation. Therefore, the presence or absence of certain vegetation types could help define climate boundaries. It means why certain plants exist in only some region and not in others. To make his system scientific and consistent, Köppen used empirical data, that is monthly average temperature and monthly average precipitation. These two variables, while basic, capture much of the seasonal rhythm of a place's climate. The complex coding system is a three-order letter system where the first letter denotes climate type, which classifies the world's climates into 6 major groups, all labeled with capital letters A, B, C, D, E, and later added H. First is A, which means humid tropical, which are basically winterless climates, with all months having a mean temperature above 18 degrees Celsius or 64 degrees Fahrenheit. These climates support dense rainforests and rich biodiversity. Examples of this type are Amazon Basin, Congo rainforest, Southeast Asia. The second major climate group is B, which is dry and arid climates. These are those climates where it is too hot that the evaporation exceeds precipitation, and there is a constant water deficiency. These areas often have little or no tree cover due to limited moisture. Examples are Sahara Desert, Arabian Peninsula, Gobi Desert, Australian Outback. The third group is C, which is humid mesothermal or middle-latitude climate with mild winters. The average temperature of the coldest month is below 18 degrees Celsius or 64 degrees Fahrenheit, but above -3 degrees Celsius or 27 degrees Fahrenheit. These regions are favorable climates for agriculture and dense human settlement. Some examples are Southern Europe, Southeastern USA, Eastern China. The fourth climate group is D, is humid middle latitude or microthermal, but with severe winters. Here, the average temperature of the coldest month is below -3 degrees Celsius or 27 degrees Fahrenheit, and the warmest monthly mean temperature is more than 10 degrees Celsius or 50 degrees Fahrenheit. These areas support boreal forests and require seasonal adaptation. Some examples are Russia, Canada, northern U.S. states. The last group in this is the E, or the polar climates. These regions have no summers, and the average temperature of the warmest month is below 10 degrees Celsius or 50 degrees Fahrenheit. They have minimal vegetation, which is mostly mosses, lichens, and tundra. These zones are among the most sensitive to climate change. Some examples are Antarctica, Greenland, Arctic Circle. Other than these 5, a sixth group was added later, which is H, or highland climates, found in mountainous regions. Here, climate varies with elevation, slope orientation, and exposure, and a single mountain range can contain several climate types over a short distance. Think the Andes, the Himalayas, or the Rocky Mountains. However, now you may think that only 6 climate groups cannot classify the climates of the whole Earth, and there may be many temperature and precipitation variations. To understand these variations, certain subcategories were added within these major groups, indicated by additional letters. The main 6 types were further subdivided into second and third-order subdivisions to classify regional climates more precisely. The second-order letter denote precipitation variations, and there were 6 categories which were S, W, F, W, S, and M. The capital letter S denotes steppe, which means semi-arid climate. Capital letter W denote desert, which is true desert. Small alphabet F means fully humid, which means constantly moist. Rainfall through all months of year. Small alphabet W is winter dry, which means dry winter season. Small alphabet S means summer dry, which is dry summer season. And small alphabet M is monsoonal, which means monsoon rain, short dry season, where total rainfall is sufficient to support rainforest. The third-order letter correspond to temperature changes with 6 categories A, B, C, D, H, and K. Here, small alphabet A means hot summer. Here the warmest month have average temperature more than 22 degrees Celsius or 72 degrees Fahrenheit. Then small alphabet B means moderate summer, where the warmest month has average temperature less than 22 degrees Celsius or 72 degrees Fahrenheit. The third temperature letter is small alphabet C, which means short and cold summer, where the summer season is less than 4 months, but with the average temperature of the warmest month is greater than 10 degrees Celsius or 50 degrees Fahrenheit. The small alphabet D means extremely cold winter, where summer is for less than 4 months. The average temperature of the warmest month is more than 10 degrees Celsius or 50 degrees Fahrenheit, but coldest month has the average temperature of less than -38 degrees Celsius or -36 degrees Fahrenheit. The next letter is small alphabet H, which is hot arid. It means hot and dry year-round with the average annual temperature greater than 18 degrees Celsius or 64 degrees Fahrenheit. Then is the small alphabet K, which means cold arid. It has cold and dry climate year-round. Here the average annual temperature is less than 18 degrees Celsius or 64 degrees Fahrenheit. For the polar regions there are 2 specially designed categories, that is T and F. The capital T means polar tundra, where the warmest month has average temperature of less than 10 degrees Celsius or 50 degrees Fahrenheit, but more than 0 degrees Celsius or 32 degrees Fahrenheit. And the capital T means polar frost with perpetual frost in all months, with average temperature less than 0 degrees Celsius or 32 degrees Fahrenheit. So, this is the full coding of Köppen's climatic system with all categories and subcategories. It may seem mind-boggling, but if you understand what the codes means, it is really easy. For example, CFA means humid subtropical with hot summers, no dry season. BWH is hot desert. AM is wet tropics with high temperatures and year-round rainfall. However, this system was made more perfect by some modifications. Rudolf Geiger helped standardize temperature and precipitation thresholds. Trewartha and Horn introduced additional detail for subtropical and temperate zones. Today, digital datasets and satellite imagery allow for climate mapping over oceans and remote regions. These updates form what we now call the Koppen-Geiger classification, widely used in modern climatology and global environmental assessments. So, why is the Köppen system still so widely used? The reason is that it operates at both global and local scales. It uses readily available data, monthly temperature, and precipitation. It provides a visual and functional correlation between climate and vegetation types. It is valuable in ecology, agriculture, urban planning, and environmental policy. That's why it remains the most globally recognized climatic classification system. But it's not without limitations. The Köppen system does not account for factors such as wind patterns, humidity, cloud cover, or temperature extremes. It may be less accurate in areas where vegetation is shaped more by soil or topography than by climate alone. Regional climate boundaries can shift over time due to natural variability or climate change. Most importantly, the system describes what climates exist based on data. It does not explain why those climates occur. Therefore, it provides a generalized picture of climate, not a detailed local forecast. Despite these challenges, it remains a valuable framework for classifying and understanding climate at the global scale. In conclusion, the Köppen climate classification system is more than just a map of climate zones. It is a powerful tool that helps us understand the interplay between atmosphere, ecology, and geography. Whether you're a climate scientist, a geographer, or a curious learner, Köppen's system provides a foundation for exploring how and why Earth's environments differ and how they might change in the future. If you found this video helpful or learned something new today, go ahead and like, share, and subscribe to my channel, Earth Diary. I'll be diving deeper into the Köppen classification in upcoming videos, so make sure to hit the bell icon so you never miss an update. Thanks for watching, and stay curious about the world around you.